Let's do it!
Come on and zoom, 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 zoom.
I'm Aubrey.
Come on and zoom, come on and zoom,
I'm Kelly.
come on and zoom, come on and zoom,
I'm Shannon.
zoom, zoom.
I'm Audrey.
I'm Kelly. Hey, I'm Jared. I'm Kate.
Today's lesson is on density.
What is density? Isn't it when objects are heavier than other objects?
Well, Kelly, density is actually a measure of how much matter is in a certain volume.
The formula for density is mass divided by volume. Mass is how much matter an object contains, whereas volume is known as the area that contains the mass.
It's easy. You just have to compare the difference in the weight of two different objects of the same size.
Yeah, we learned in science class that things with a less density will float and things with a higher density will sink.
To the lab!
Come on and zoom, come on and zoom, zoom, zoom.
For this experiment, we need 2 glasses of water, salt, and eggs. First, we're going to take a tablespoon and a half of salt and put it in one of the glasses. Then you mix it up. Then we're going to take both of our eggs and drop one into the one with salt and one into the one of just normal water. As you notice, the one with the salt in it floats. Since density is defined by how much matter takes up a certain amount of volume, we can take our ordinary water, add it to salt, and make it denser. While the volume increases a little bit when we add the salt, the mass increases by a much bigger factor. This is because rather than just floating around and taking up space, the salt dissolves into ions which are attracted to the water molecules and bind very tightly to them, packing more matter into the space. The mass of the ordinary water consists of the mass of the hydrogen and oxygen that it contains. In other words, the salt water that we create has more stuff in it and always has a density greater than 1.0 and is much denser than ordinary water that has a density of exactly 1.0. So how can we prove that salt water is denser than ordinary water? By understanding that the higher density of a fluid, the easier it is for things to float in it. You can think of the salt water as having more particles with which to hold up the floating object.
Here we're going to talk about what makes boats float and pennies sink. So, Audrey, which one do you think would sink and float based on the weight of them?
Well, this container seems heavier than this penny, so I think this container will sink.
Well, let's test it out. So we can see what happened. The penny is here on the bottom, and the boat's floating up here. What do you think makes this happen? Well, it's a little principle called density. The density of this penny, since the molecules are packed so tightly together, it makes it sink to the bottom. Whereas this boat is filled with air through the sides, and air is less dense than the water, so it floats on top. The two opposing forces working on the boat are gravity and buoyancy. As gravity pushes down, the force of buoyancy pushes back up. This force of buoyancy is caused by the displacement of water, forcing the ship to rise back up. In buoyancy, when you press down with an object, the force of the water that is being displaced pushes back up. So if this boat was 1,000 pounds, we would need to displace 1,000 pounds of water in order for it to float. When I push down on the boat, it pushes back up.
When comparing liquids, oil and water don't mix because of molecules. Water molecules are very tiny and are more attracted to themselves than oil molecules. The density of oil is less than that of water. That's why oil floats on water.
Audrey, do you think that air has weight?
I don't think so. It doesn't feel heavy around us.
Maybe we should test that.
All right. This balloon is filled with helium. This balloon is filled with air, which is also known as CO2. What do you think will happen? 1, 2, 3. Helium floats in the air, and CO2 sinks because it is denser than the air around us.
The density of several gases is compared to the density of air. If an object containing a gas floats on air, it is less dense than the air versus if it sinks, it is more dense than the air. The higher the molecular weight, the higher the density. The helium balloon floats on the air and is less dense than the air. The air-filled balloon sinks because the weight of the rubber balloon makes it slightly heavier and thus more dense.
That's it for this week's episode.
Come on, you guys, go.
Bye!
Come on and zoom, 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 zoom, Zumba, zoom, zoom, zoom.
Forgot to put on the music. Well, it's gonna be overlapped, so we. Yes, it's still playing. Okay, cool.
I'm not ready for this. Oh, it's gone. Okay. I'm Audrey.
It's supposed to do that.
It's almost floating. I'm gonna add more salt.
I was like, where do I look? Where do I look?
Yeah.
I feel like I should be over this way a little bit more.
And then do that laugh.